Hmm. There is this image, let us a test image, very interesting one. You can see for this particular image, there is, okay, everybody. So these random mates are very tricky. Okay, okay, huh. So you can see there are different shades. Okay, there is from white to light gray, mid gray, dark gray, then black, and then there are these lines from small a to capital A with different widths. Okay, with different widths. Okay. That also interesting. Then there are these, boxes from smallest size to largest size, and then there are some dots here. Salt and pepper, that's what the author likes to call them. Okay, it's a very very interesting test image. And then there are these lines. Okay, then there are these lines, some of them thick, some of them thin. Okay, some of them thick, some of them thin. So this image actually lets us, tells us exactly, for comparison, the filtering action and all those things. Okay, very interesting image. Okay. Now once I've seen the image, now let us go back to the MATLAB thing. Now let us go back to the MATLAB thing. Okay. So what do we have in MATLAB now? Okay. So the first thing, what I'd say now, let me read that particular image here. Let me read that image. It's a three-dimensional for some spooky reason. I don't know why. So I have read that particular image. Letters dot BMP. That's the image. You know how to read. So you can see, I see here the image has three dimensions. Okay, image has three. Let me convert the image. Okay, let me convert the image. So whenever you are using the ready command, imhist, you don't have to do that. Okay, you don't have to actually do that. Okay. So image is available. Now let me show you how the masks will be. How the mask will be. Let me show you a typical mask. See here, I have taken n is equal to 5. Then I have defined a mask. So what is the mask? Once n comma n. Okay. So if at all I have n is equal to 2, for example, then it will be 1, 1, 1, 1. Okay, 1 1 1 1 divided by all the values divided by 1 by 4, so that when I add them, the numbers all add up to 1. If at all I have n is equal to 3, then it's going to contain 1 1 1 1 1 1 1 1 1. Then afterwards all these numbers should add to 1, right? That's why after this I will have 1 divided by 9. Okay. Got the thing. So here I have written this small piece here. So what I will do, I will create my mask. It's a normal averaging filter. Then let me filter it. I am not using a convolution or correlation function here. I will rather use IM filter, the ready function. When you use IM filter, you need not be bothered about the zero padding. You need not bother whether it is having how many dimensions, whether it is two-dimensional or three-dimensional, doesn't matter. It knows that it's an image and it will apply to each and every dimension automatically. Okay, automatically. Okay. Otherwise, if at all you are using specifically convolution or correlation, you should somehow convert it to RGB to gray. Okay. Now let me apply the filtering. Okay, let me apply the filtering. Let me run this thing. N is equal to 5. Okay, okay. Let me do n is equal to 3 to begin with. Okay. N is equal to 3, and the mask will get displayed here. Here is my mask. This is like mask is nothing but my impulse response. You can see my screen, right? MATLAB screen. So this is my mask. Okay. So 0.111 divided by 9. Okay, that's it. If at all I if at all I have n is equal to 4, instead if at all I have n is equal to 4 here, n is equal to 4 is not a good one. I was telling you earlier, right? It has to be, it's good that it has a midpoint. Okay, this is a mask for n is equal to 4. Okay. Now let us see the action. So how does it work on the image? Okay, let me go back. Have n is equal to 3 case. So the function used, IM filter, whichever the image which I have used, and I will do this mask and I will show you the image. Before that, let me display the original image. Let me display the original image. Original image is here. Original image is already open. Now let me run this thing, and you have to tell me if at all you can find any difference, if at all you can find any. Let me share with you the screen. Okay, let me share with you the screen, my MATLAB screen. Both have popped up now. The screen, okay, yeah, there. Hmm. So on one side I have this image, the original image. Can you see my screen? Not the MATLAB, with two figures. So on one side I have, the original image. One side I have the original. Can you see it? Can you see the screen? The original image and the filtered image. Can you? Somebody ping. Can you see this? Okay, thank you. There is original image, then there is one. Now, by the way, I just asked you, can you see this border here? This is not a frame or a Photoshop thing. This has occurred actually because we have not zero padded. Remember, we have not zero padded. So what has happened is, so whenever there is lack of image, MATLAB assumes zeros on the left side. Okay, zeros on the left, zeros on the top, zeros in the bottom. So since this was a 3 cross 3 mask, two rows and two columns of zeros were assumed on the top, bottom, left and right, and they were processed. So what happened? The first zero plus 0 plus 1. Okay, 0 plus 0 plus 0, it was a dark gray, then there was a light gray, then there was a mid gray. So you ended up getting, since 0 is black, you got this frame. Okay, you got this frame on the left and frame on the right side. Okay, got this particular thing. It is also importance of zero padding, or I should know, I don't say important, but it's a consequence of zero padding. And then you can see the blurriness here, smoothing, let us call it smoothing. It's too edgy, right? You can see here, this is too edgy. It looks like some optical illusion here, but this is looking dull, sort of soothing image, Now, did you observe the thing? Somebody ping, somebody, please message me. Did you observe the thing? Now let me make this n is equal to 5, a higher order, and let me once again display the image. N is equal to 5. Okay, so can you see the thing? The newer image, can you see three images by the way? Figure 3, screens. Okay, wait a second. Can you see three figures? Wait a second. Okay. Having some issue loading the, what happened? Okay. So can you see three figures here? Okay. So first one, second one, and third one. Can you see the effect of smoothing by the way? So first one, the original image, little smooth and much more filtered image. What apparent difference is, so you can see this initial dark dot here, it turned out to be larger blur, little larger blur because of the values on the left and the right, and here much more blur. Okay, much more blur has occurred, and you can see the difference in this particular A, and these patches are suddenly turning out to be average gray. Okay, what this particular thing? So that is the impact, and you can see this border is now getting much and much thicker. Okay, okay, everybody just type in a hi. Everybody just comment. Everybody just comment in the comment section something you type. Something type some hi or something. You forgot to do that. Okay, okay. Got this particular thing. So that is how typical this thing, MATLAB thing works. Okay, so tomorrow what we will do, let us stop today. Okay, most of your friends also got bored. I think they have one more class also now. I will stop here today. Let us continue tomorrow with the Gaussian filter. Okay, let's continue tomorrow with the Gaussian filter. Thanks for joining. Okay, I will stop.